Great, great. So welcome to my show. What I've tried to do here on behalf of James is to talk about what we've seen in a variety of different industries. James did come to me with a discussion about IoT and how that's going to play into this. But the reality is, for the most part, we are very familiar with physical asset inventories, but we're not very good at doing software and electronic maintenance and inventorying of those assets. And as these systems become more and more connected, we are winding up in a case where it's actually going to get harder before it gets better, especially as we transition to more digital world. So I like to start my presentations with an anecdote, and this one's a bit of a tongue-in-cheek, but nonetheless, the first 90% of code accounts for the first 90% of the development time. The remaining 10% of the code accounts for the other 90% of the development time. So most of us are familiar with the 80-20 rule. But what Mr. Tom Cargo at Bell Labs said quite some time ago was it's the 90-90 rule, and you end up spending 180% of your time developing and owning a solution. So you don't just buy a solution and put it in, you end up owning it for its entire lifetime. So there were some excellent presentations that hinted on the frameworks that you should use, some of the components and capabilities you should have, and I'm keeping this very high level on purpose. OTSM or OT systems management is foundational for today and also for tomorrow. If you don't know what you have, you can't make informed decisions. This does get harder when we're dealing with manufacturers that are actually arguably integrators. So a train is actually probably very similar to an aircraft in the sense where Boeing, Bombardier, or Embraer, when they build an aircraft, they don't really build an aircraft. They're actually the companies that put all these pieces together. They're integrators. So it does make things a little more challenging, especially when you're finding parts being reused and rebadged under a different name, or they're using open source components. How do you know what is what inside what? But nonetheless, though, asset management is critical for your change control and identifying areas for your future improvements. It's important for your gap identification and remediation. It's a foundational component if you're looking at all of your asset data and you're able to visualize it and build the right insights out of it. It is a great way to get an idea of where some of your security risks and your threat management activities should be focused. It is not only critical for being a stake in the ground and saying, I have this asset here and on that device, right? Or ABC PLC, it happens to be an XYZ train. It's more than that, right? It's a bunch of other things. You need to manage your erratas with this type of stuff. Anomalies, you'll get advisories for operations. All of that stuff can be tied into your asset management, but it's not done very, very well for electronic systems for a variety of reasons, especially with transparency issues. It's also a great way of knowing your infrastructure health and limitations. And a key part of this is asset management is much more than just looking at your devices and your Windows systems and your HMIs and your technician laptops. It's also a good way of getting an idea of how your third parties are interacting with your assets, assuming that you have a mobile record with those systems, and also a good way to provide a baseline for cyber insurance. So if you don't have good asset inventory and understanding of your assets, chances are you're probably not going to get a payout or even be eligible for insurance at a later date. For most of us in the room, we recognize that there's three main families of assets. We have our fixed assets versus our transient versus our IoT. Our fixed assets obviously are the easiest ones, the most simple out of all of them from a logistics point of view to get connectivity to. Even the serially connected ones are the ones that are talking over a bus that is a time-delimited bus, for example, like an A-Rink system that's used in aircraft and trains. You can always do a gateway and get access to those systems. The transient assets are a bit of a different kind of problem where they go in and out of connectivity ranges. They might not have cell service. With mountain ranges, you might not even have satellite internet. So those ones are largely where these last two categories are where I'm going to focus most of this presentation on. And then we have our standalone IoT assets or IoT-ish assets that are promising these turnkey solutions. And this is kind of another problem that's related to this, but it's also an area where we need to improve. If we keep tacking on IoT assets to our current infrastructures that are a hybrid of legacy and modern systems, we're going to find out that our risks are being magnified and amplified because some of those risks might not have been present before for various reasons, but now they will be because someone's put in bidirectional connectivity to our systems. And so a gentleman named Dale Peterson kind of laughed with what I was saying earlier about IoT assets offline. was they might promise a lot of things up front, but the gains that you will get today will negate quicker than you think, and they will quickly degrade over time, because you end up having to take care of them and treat them just like they were the legacy assets of yesteryear. So an IoT device is just a PLC of yesterday. It just hasn't happened yet, but it's coming. One of the things people think about when we're looking at electronic maintenance, and I put this slide up here on purpose, there's this big push for passive anomalies or passive asset detection. They're terrible. They're often wrong by a magnitude of 10x. Under the best of conditions, they could be accurate up to 70%, but that's very, very rare, and it's superficial. So they can identify the existence of devices, assuming you have connectivity, of course, and there's various problems with that. It's superficial, but many organizations also tie this data into a manual process, or they're tying it into their ServiceNow, CMDB. But there's a low frequency of updates, and this lacks in-depth verification. I'm not saying you shouldn't put in those things, but what I'm saying is they are better tracked and augmented in a system that is nearly real time. Something that is able to do more. So for Windows boxes, you can put agents, and you can do many, many things that are safe for OT. 20 years ago, if you read a manual for an HMI, it might have said, disable your firewall, do not touch it, don't do this, don't do that. Now they almost all say all of the best practices that an organization like SANS or their derivative of CIS might tell you can do those things now, and they've been recommending it for quite some time. They acutely can enumerate the details of an asset. This is much more than looking just at packets and network flows. You might be able to discern from network traffic that something has an Intel Mac, assuming there's no routers clobbering your MAC addresses. You might be able to determine that it's a Windows box, roughly a Windows 7 or 2016, based on some leaky traffic for SMB. But it's not enough to know what's actually installed. If it's installed and maybe not broadcasting, or there's no connections to it, you'll never see what it is. Or because we're working in industrial systems, they don't broadcast that type of data and only under certain conditions. So for example, certain types of packets for industrial PLCs are only created and being sent when a system is being queried by an engineering station during boot up, or under some sort of anomalous condition or a specialized logic query. So there's a lot of other assets here that we need to get into these systems to be able to track more so, especially if we're tracking anomalies or tracking risks that we should. So we might not be able to do anything about them, right? Work needs to be scheduled for a maintenance window. Maybe there's no fix, but we do need to track those things. And just looking at things on the wire is a very terrible way to be doing so. And also, looking at things in a more active way, especially if you can interrogate assets under various conditions. That is the right way to do it, and we've seen it done successfully in other industries. So I'll start with my first case study. We're in the business of trains, so we're used to imagining moving parts, but we're not probably used to managing moving parts that go through multiple countries. Now, rail in Europe arguably is very different than rail in North America. But aviation is very tricky because a lot of carriers deal with problems that you and I probably can't comprehend on a regular basis. These are mobile sites. Oops. If we take the aviation ecosystem, we can see that many of these high-level areas overlap those in trains. We have data links and satellite comms. We have avionics, which would be similar to train control. We have connectivity in the equivalent of a yard, right? The airports or inside of the hangars. We have technician laptops that go in and out to these trains. We have OT infrastructure that is our tank farms. You have waiting systems for trains to see if you're under your maximum capacity. You have storage. You have terminals, cranes. All of that stuff is also there too. We also have other cases where trains, oil and gas tank farms, and rack sales and airports are all tied together. And these are all moving assets. But the one thing that separates out aviation from some of the other industries is that most airlines do not transmit continuous data from their aircraft while they're in the air. They can for a very, very costly fee. And in some places in the world, they can't because there is no satellite coverage. But what they generally do is they store the logs until they're what's called weight on wheels, when they're sitting on the tarmac, and then they can transmit. They usually pull those logs off either one of two ways, with a technician laptop or some sort of data link, or they will there's maybe an LTE gateway or a GSM gateway at the airport, and then they'll transmit them to a file dump, and then those will be grabbed and ingested into a SIM. So that specializes in these things and those use cases. But there's periods where they have no connectivity. So if you're flying from Vancouver to, let's say, Tokyo, to Narita Airport, those logs for over that entire journey in one direction won't be transmitted, and they also won't be transmitted on the other direction until they're back on, let's say, Canadian soil, because that airline has not purchased cellular connectivity in the other country. So there's a lot of challenges there, and also how do you get parts in one location or another? And we'll talk about some of the other pieces as we move to more electronically based secure assets as we go ahead. E-enabled aircraft are using cryptography in a way that nearly no other industry is doing today. And so there's some other use cases there on asset management and what their implications are. But nonetheless, though, this is one of the things I want to talk about. How do we deal with those moving assets? And the one way was to wait until you're into a situation you can control and pull the logs, but do acknowledge that you have a very large delay. Our second use case from oil and gas is kind of a crossover between the airport and the oil and gas industry in Vancouver. So Vancouver Airport consumes 8,000 Canadian gallons a day, which is 8 million gallons. So 8 million gallons times 4, a very large number. They have tank farms. Trains always have tank farms as well. They have terminals. So when you have transportation issues, there's roughly a 68,000 barrel a day refinery in Vancouver that provides the fuel. Then you have all of the gauging in between. You have flight ops. And the air traffic control at YVR and in other airports around the world, they actually communicate with the pipelines in real time to know how much fuel they have in stock or how much they can predict based on, for example, a large number of wide body aircraft coming in. So they're dealing with this stuff on another sense, but all of these are assets and all of them are under different business units. And all of these things aren't just a level bar of maturity across the organization. You acquire assets, you divest assets. Some business units that were left on their own for many decades, and now they're being brought under another umbrella. I know this to be true for some of the other rail companies in North America. So there's all of these things that we need to put together, and they all will need different strategies: mobile laptops, mobile data acquisition devices, acquisition gateways, like, for example, LTE RTUs, which represent another set of risk vectors that we typically don't think about. Is, can you trust your ISP? Can you trust the management mechanism for these RTUs? Probably not by itself. How do you manage the PKI to deal with all those distributed assets? Another overhead problem, including assets that are out of your reach altogether, which would be GPS and satellite links, which rail largely relies on. So in our third case, moving at rail, what I really want to pose in front of you is, if you're having a hard time managing electronic assets today, you can do so feasibly in OT, but maybe take this chance to look at what you have today, what you can do with it, and make sure that you have that under lock before you move to adding more electronic assets that are probably going to have shorter lifespans, quicker end-of-life schemes, and then more frequent updates. So if we look at this kind of partial view from 65,000 feet of rail, we see a lot of the same assets starting to show up, or let's say categories, right? The terminology changes between rail, aviation, oil and gas nonetheless, but a lot of the components are the same components. For example, a PLC that's used for discrete manufacturing might largely be the same PLC that's used in rail, but the rail version has different environmental certifications. It's better for situations under high pressure or high vibrations. So there's all of those systems there. But when we're looking at rail, and I'm thinking of the Rockies when you go across in a train, or when I was in the south of Germany, there were periods where we didn't have connectivity. Now, arguably, some of the issues with wireless inside of tunnels has been dealt with for roughly a decade. So we can get data in a lot of situations. But if you're going between Montreal and Ottawa on rail, there's periods where you have no cellular coverage, and so satellite would be the only way, or you would just wait between bases. It really depends on what you need for real-time access. If you're able to control what goes in and out of these mobile sites, as I call them, then you're in a better chance. The problem, though, is that trains are largely starting to become like aircraft, where you need to make sure that when they are sitting there on the tracks or unattended, that, for example, you'd never see an airplane with an open cockpit while it's sitting on the tarmac. The plane is always locked up. So you're going to wind up with more physical controls. But nonetheless, though, these are all assets across the board that we need to be managing in different variations. And some will overlap with IT. Some are IT assets that are providing OT functionality, and some are pure IACS assets, industrial automation and control systems. So when we're looking at things like with connectivity and some in discovering assets without, we need to keep in mind a few things. And I heard air gaps mentioned earlier, and they can be a feasible alternative and approach. The problem is that they are great on paper, and I almost have never seen one being cleanly maintained over time. Security always degrades over time. Security is a function of time, let's face it. But it's all about the equation of balance. Things can be done if you secure the access and challenges. So if you're looking at another cybersecurity standard group, ISA, and their 62443 standards, or IEC's derivatives, they talk about zones and conduits. And so if you're dealing with modern connected networks that you own, right, that might be some of the mobile train assets, and they might have always on connectivity. Those aren't too bad to secure, and they are not too bad to integrate into asset management systems. If you do have a good understanding, for example, of the serially controlled devices, often you can get to them through a gateway. Now, I don't recommend that in all cases, but you can get to them, and sometimes it is better to deal with them. Tank gauging and correction flow meters, those are things that are often connected in the oil and gas world, and they are able to be inventoried on a regular basis. And they're a good way to see if things are floating out of calibration or not. This isn't just for IP-based systems. You can get more here. You have various other edge cases, though, that you need to work around. Like I said, mountainous terrain, cases where things are absolutely to be locked down, like cryptography, the locomotives themselves, the maintenance groups. Those aren't so bad. But when people start tacking on your IoT devices and they're completely outside of your realm, then you have to maybe do other ways to try and find them. You might have to do signal analysis over the airwaves and with, for example, SDRs, and look for anomalous devices transmitting, which might be very tricky, especially in noisy environments where you're generating electricity with generators on a train to keep the troop moving. You might not be able to see it because of the spectrum noise. But nonetheless, though, you can discover and deal with those assets. So as I said with James, there's many ways to get value here and to be able to reverse engineer and get to a solution. I want to put it before you. This vision of digitalization has been occurring since the 1980s in the oil and gas world. Systems were designed to be converged, and openness of data has been around for decades, really. But it is a future nightmare that the other industries have probably largely already seen, and it promises profit. But when we're starting to move towards more modern assets, the benefits of some of them are not necessarily clear cut, right? There's the total cost of ownership that isn't factored into managing assets. And that's why it's critical to get a detailed understanding of your assets. So I won't talk about the pros and cons of data, but what I do want to talk about are these two main points here in bold on the right-hand negative side. The more assets you add, especially the more frequent they change, the more cybersecurity and electronic maintenance you will have to do. When we're talking about maintenance, it is not just applying patches and making sure that things are operating and that, for example, a network card isn't flaking out, or a wire is frayed and so the shielding has a problem. No. Electronic maintenance is not just the implementation and the security of the device. It's also managing it from cradle to grave and figuring out what the transition will be after the fact. That device that you're probably going to buy that's running an ARM CPU today will be out of date, and your manufacturer will not be able to, your OEM will not be able to provide you a one-to-one copy of it at a later date. It'll be a new product that probably isn't going to be compatible with the old ones. And so you need to start thinking about things in this overlapping and weaving technology transition project. Nothing is forklift, despite what we might want to believe. All of this, including the users, needs asset management and real-time reporting of it. We're getting to the point where connectivity is almost ubiquitous. And so we can instrument these devices to at least be putting data into a place, and maybe it goes over a data diode or not, but they do represent risks, and we can leverage that in a way that's beneficial, and we can get that data into something and make use out of it. Now, data is only good as our use cases, though. So what I'm trying to say is asset data or asset management and the data that's generated from assets is a foundational piece to ensuring your security and your maintenance of your assets. I have a couple interesting use cases coming up, but the understanding of whether or not loss in revenue or generators is already really understood. But you shouldn't be expecting assets to magically manage themselves. You shouldn't be expecting one OEM to be able to manage multiple solutions and different vendors. That's also a big piece in other industries where a refinery is not just, I don't know, pick one OEM like Honeywell. It's not just Honeywell. It won't just be Yokogawa from Japan. Aircraft is not just, let's say Boeing. Boeing does kind of put it together, but you'll have, for example, GE Mark 6 Aviation DCSs inside of it instead of the LRUs. You'll have a variation of other things. You might have relays from Rockwell that are controlling discrete valves elsewhere or Emerson. You will have multiple vendors here, and you need to tie all that together. If you add in another, maybe a very short-lived IoT device vendor that's going to get bought out or disappear off the map, that's another thing you're going to have to own. And you're going to have to understand the data that it can create or make. And you're going to have to put all that together into a situation that you can understand. So your SOPs might need to be adjusted for each of those vendors in relation to your asset management. If you're seeing certain symptoms, okay, that calls you to look up those features in a certain way. There's a lot of stuff there that needs to happen. And it's not just about buying and dealing with an asset and recording it on a data sheet, and when it's dead, it's dead. Or you sell that asset. It's much more than that. All of it needs to be one way. For safety reasons, I know and I believe that most of the things around mechanical replacements are very well maintained, but electronic I highly doubt, because I see that in other industries. Maybe one particular set of rail, for example, that's modern, like, I don't know, let's say Translink in Vancouver, they might be far more better suited for doing electronic maintenance, but another one that is a more mechanical ad hoc system that's over multiple eras, like the Montreal STM, might be a bit different. Or if you're in another country which roughly uses the same trains as Paris and as Montreal would be Mexico City, then it gets a bit trickier there as well. But there's always a cost to assets and their ownership, and that cost of ownership is always understated, and so is the cost of obtaining the data and making use out of it. It will make your vulnerability management teams much more difficult. It will drive a lot of your decisions, but it will require a lot of effort to maintain. So I do want to give a case in point of why some of those assets are much more work than you think they will be. This is a Raspberry Pi, of course, but it was being used, and I know there's a rail company in Canada that is looking at implementing Raspberry Pis for data acquisition on board their passenger carriages. But the Raspberry Pis are an interesting problem. Yes, they're ubiquitous. Yes, they are everywhere, so you probably won't have a problem with them. But when everyone starts rolling out their own Linux distributions, Linux is not fraught without its own issues. And neither is a proprietary system for that matter. But if you take something that's packaged up in a product and you know it as ABC brand, and you don't know that it's running Linux, or you know it's running Linux, but the OEM is taking care of it because they said it's a Debian derivative, there's also a lot of other software installed, right? And in this case, there's 1,520 packages, and there was actually over 200 vulnerabilities in them, in the overall collection of packages. You can't just go apply apt-get and do an update on it. Besides the connectivity problem, you have different architectures and then other things on how that system was made. In that case, there was no space set up. And so you would actually corrupted the disk and you'd have to start over. Or you needed to generate custom SSH keys to even get access in the first place. So there is a bunch of problems there in looking at these new assets as they go in there. There's much more. Now, I will say this. Just because you see something with, like, say, Linux kernel 4.1997 here, it doesn't necessarily mean that things are secure or vulnerable. And what I mean by that is each OEM will roll out their own firmware, and they might have their own patches on a Linux kernel. They might only have certain modules installed. So the presence of a vulnerability does not particularly mean exploitability. So I will put that forward. But in that case, if you're doing asset management, you're not doing detailed asset management, you would see that you'd probably show up with a Raspberry Pi integrators MAC address, right? In this case, I think it's a Broadcom MAC address that would show up. You might see that it's Linux, but you probably won't. And then you see a few other pieces.
3 minutes there, Ron.
Great. Just wrapping up. So I just want to keep that in mind on who is maintaining those systems. The last point here that I kind of want to just drive through is airlines. So airlines were dealing with all of these logs on these aircraft, and every aircraft is different. So you do need to manage that in a different way. They all roll off the line different from each other. But the reason why I'm putting logs here is that it actually showed issues with the asset management. And the issues to the asset management was on how they were doing their encrypted parts. So they have this concept of LSAPs and crates. And so they're signed and built for one plane, and they're taking parts and putting them onto other trains. And those would generate cryptographic log errors, and you'd have to manage those issues. The other main point to add is that OEMs are not omniscient. They do not know all of the logs that come out of their systems. In this case, some of the airlines actually had to provide their logs to the OEMs because they didn't know what they were, and the airlines actually had a better understanding of which logs would be generated under what conditions, and the baselines provided by the OEMs in the first place were wrong. So what that means is you as an asset owner have to also work with your relationships with your vendors and tie all that together to get proper asset management in a coordinated fashion. So my 6 ending points here, don't undo your safety and security while chasing dollars and cents. I know this sounds like common sense, but it is a common issue. So it's common enough for me to talk about it today. This is a people, process, and technology issue. Ensure that your basics are in place. If you want to add more transient distributed assets that are standalone, be aware that there's going to be a cost there, and you're going to incur a risk that is probably going to be amplified and magnified. Digitalization is going to require more security. That's how do you manage your PKI? How do you manage your management interplanes? Choose management enablers in action. Insights and alarms are valuable, but you also need to have assets that can generate those things. If you focus only on the data that comes out of sensors, you're probably skipping some of the key points. On aircraft logs, we could actually determine when hardware is failing just by some of the logs. So we were actually able to tie some of that into the preventative maintenance schedules. And clear objectives are a must. Don't just add devices without a clear mission with considerations to the other ones. And on that note, I'm good.
Awesome. Thank you. That's Ron Brash, Verve Industrial Security. Thank you, Ron. Virtual round of applause there for you. I'm sorry there wasn't enough time really to talk about this really super intense subject, but we do have 10 minutes of Q&A with Ron Brash in the sessions area starting now. And anybody who has questions about this, head over to sessions, talk to Ron. I'll be there to let you in. And after that, we come back at 7:20 with Mickey Schiffman of Silas to hear a really unique case study from him. So without further ado, thank you, Ron. See you in a moment.